are starting to learn about equivalent fractions. To model today's lesson, I am going to go over a couple example problems on the lesson 4 homework. To start out in letter A, they have taken this whole rectangle and divided it in half, hence the thick line in the center. That is why this bracket here is labeled 1/2, because there are two big rectangles and one of them is shaded. So one out of the two pieces is shaded. They then took each half and split each half into thirds. That is why there are two dotted lines on each half. They also split this half into thirds. Now, instead of having two equal pieces, I now have 6 equal pieces. 1, 2, 3, 4, 5, 6. Now, each of these shaded smaller pieces represents 1/6, because one piece is shaded out of 6 total pieces. In this 1/2 side that was shaded, there are 3 1/6 pieces. So we can say 1/2 equals 1/6 plus 1/6 plus 1/6. 1/6 plus 1/6 plus 1/6 plus 1/6 equals 3/6. So this problem is saying that 1/2 equals 3/6. Now there's a way to check to see if this is correct. When we do equivalent fractions, there's a rule that we follow. And that rule is, whatever you do to the bottom, you must do to the top. So the first question I ask myself is, what do I multiply by 2 to get to 6? That answer is 3. So if I multiply the 2 times 3 to get 6, I must also multiply the numerator by 3, or the top number, because in equivalent fractions, what you do to the bottom, you must do to the top. So I can check to see if these are equivalent, because 2 times 3 does equal 6, and 1 times 3 does equal 3. Therefore, 1/2 does equal 3/6. Now what they want you to do is they want you to come over here, and still we have one big rectangle that they have split in half. That is why this bracket is labeled 1/2, because there is one big piece shaded out of 2 big pieces. Then what they decided to do is to split this half into fifths. That is why there are 4 dotted lines, because that now makes 5 pieces on each side. Therefore, the total number of new pieces is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means one small piece now equals 1/10. So in this half, we have 5 1/10 pieces. That is why it says 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10. I know that equals 5/10. Therefore, 1/2 equals 5/10. And again, I can check and see if this is true, because what I do to the bottom, I must do to the top. So I have to ask myself, what can I multiply by 2 to get to 10? That answer is 5. 2 times 5 equals 10. Since I multiplied the denominator by 5, I must multiply the numerator by 5. So I can check my work. 2 times 5 does equal 10, and 1 times 5 does equal 5. That means 1/2 is equal to 5/10. Down in letter B, I'm going to show you the first tape diagram, and I'll leave you to do the second tape diagram. So in this first tape diagram, we have one big rectangle that they originally split into fourths. That is where the solid lines are. 1, 2, 3. So as you can see from those solid lines, I have 4 big pieces. 1, 2, 3, 4. So one shaded big piece is 1/4. Then they took each of the fourths and they split them in half. That is why you see the dotted lines. So now, instead of having 4 big pieces, I also have 8 smaller pieces. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, one of these small pieces equals 1/8. And then this other small piece equals 1/8. So that means I can say 1/4 equals 1/8 plus 1/8. I know that 1/8 plus 1/8 is 2/8. So they are saying that 1/4, which I'm going to write this over here, they are saying that 1/4 equals 2/8. And again, I can check this work, because with equal fractions, what I do to the bottom, I must do to the top. So I have to ask myself, how do I get from 4 to 8 by multiplying? That answer is 2. I multiply 4 times 2 to get 8. And what you do to the bottom, you must do to the top. So I must also multiply the numerator by 2. So now I can check my work. 4 times 2 does equal 8, and 1 times 2 does equal 2. So I know that 1/4 is equal to 2/8. So I'm going to leave this one over here for you. You'll notice the big piece is still 1/4, but they split each 1/4 section into fourths instead of halves like they did over here. I'm going to do one example problem from the bottom to model how you have to split the boxes up, and then I'll leave the rest for you. So this big rectangle here equals 1 whole. And this rectangle is split into fourths. That means I have 4 big pieces. Now, 3 of them are shaded. So this bracket represents 3/4 because 3 out of the 4 pieces are shaded. Now, what they want me to do is they want me to decompose this in at least 2 different ways. Decompose means break it down into smaller pieces. So it's always easier for me to start with halves. So I'm going to split each of these fourths in half. So I'm going to use dotted lines so I can see that it's separate from my solid lines. So now I have 4 big pieces, but I also have 1, 2, 3, 4, 5, 6, 7, 8 small pieces. That means each of these small pieces equals 1/8. So I'm going to label each of the shaded small pieces. So that means 3/4 equals 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. So I have 1, 2, 3, 4, 5, 6 1/8. So this equals 6/8. So what they are saying is 3/4 equals 6/8. And again, I can check this work. I have to ask myself, what do I multiply by 4 to get to 8? And that answer is 2. So if I multiply the denominator by 2, I must also multiply the numerator by 2. So I can check my work. 4 times 2 equals 8, and 3 times 2 does equal 6. So that means 3/4 is equal to 6/8. Now on the second one over here, again, you'll notice there's 4 big pieces, and 3 of the pieces are shaded. So the top fraction is still 3/4. But now you have to decide how you want to break up these big pieces. Do you want to break them into thirds or fourths or fifths or sixths? That is your choice. So I will leave that one for you. Same thing in letter B. You need to figure out what the whole fraction is here, and then you need to decompose or break apart these big pieces into smaller pieces. So I'll leave those two for you to try as well.